looking at problem 3. Find the area between these two curves on this given interval here. So I think looking at the graph will be helpful here. So we've got it on Desmos. This blue one here is the 1 over x plus 1, and then the red one is the x minus 1 over 2. It's actually a linear function. It looks linear, it is. So notice on the interval from 0, here's 0, to 4, here's 4, the functions cross each other. So we have to figure out what that point of intersection is. Set up our first integral will be the blue one minus the red one up until that number, so 0 to that number. And then the second interval will be whatever that number is to 4, where the roles have reversed. Now the line is the one that's bigger minus the other one. Alright, so the goal first then is to figure out what is that point of intersection. So let's do that. To find the intersection value, x value, set the two functions equal to each other. So 1 over x plus 1 is equal to x minus 1 over 2. Probably the easiest way to solve this is to cross multiply. So 2 times 1 is 2. Let's write it like this, x squared, or not x squared, sorry. It will be squared after we multiply it out, but it's x plus 1, x minus 1 is equal to 2. That's the cross multiplication. Now when we do multiply this, we get x squared minus x plus x, that's canceling, and then minus 1. So x squared minus 1 is equal to 2, and x squared is equal to, add 1 to both sides, we get 3. So that intersection point that we saw was root 3. And we're not going to care about that other root, the negative root, because it's not on the given interval. So the integrals we'll set up will be total area. Let's see, I forgot which one was on top. First, the 1 over x plus 1 is the top function. So our first integral will be integral from 0 to the square root of 3, and then we said 1 over x plus 1 is the top function there, and then minus the other one. Now that other one I'm actually going to write it, well, for right now let's write it like this, x minus 1 over 2. Alright, so that's the idea. Now let's go ahead and make it so that we can actually integrate this thing. Okay, so 0 to root 3. I'll leave that first one alone, so that's going to be x plus 1. In fact, let's just go ahead and split this up into two integrals. It'll make it easier. And then minus the other integral. Still the same bounds, 0 to root 3. Now, what we have here, when you have something over a constant like that, you can just put the constant in front, or you can like split it up as two different things. So let's do that. We can actually write this as 1/2 x minus 1/2. That's going to be much easier to integrate it if we do that. Okay, so the first one, we're going to do a little substitution on that one. We're going to say u. In fact, let's just notate these. That's the first integral we're going to do. This is the second one. Alright, so the first one we're going to say u is equal to x plus 1. So du is dx. So with that, the integral changes to be 1 over u du. And the lower bound changes, was 0, becomes 1. Upper bound, root 3, and now becomes root 3 plus 1. Remember that you have to do that on these definite integrals. Okay, so that's the first one. And then 1 over u, the antiderivative there, is natural log of u. So natural log of u evaluated between 1 and root 3 plus 1. Okay, so we're going to plug in root 3 plus 1. We'll get natural log of root 3 plus 1 minus the natural log of 1. The natural log of 1 is 0, so that term is basically just going to go away. So that's what we get for our first integral. Second integral, we'll get same bounds, 0 to root 3, 1/2 x minus 1/2. When you write it like this, you can see it's linear. It's much easier to integrate. So raise that to the second power, divide by 2. We're going to get 1/4 x squared. That one becomes just 1/2 x. Plug in our two numbers, root 3 and 0. So we're going to get 1/4 times root 3 squared minus 1/2 times root 3. And then we plug in 0, it's just 0, so this thing becomes, square that, we get 3/4. 3/4 minus root 3 over 2. Okay, so putting these together, integral 1 minus integral 2, we're going to get, for the area, if we've done both of these, area is going to be equal to, and actually, let's go ahead and call this area 1 because we still have another one to think about. So, let's see, for the first integral we got natural log of root 3 plus 1, so ln root 3 plus 1. And for the second one we got that, but remember it's minus, so integral 1 minus integral 2. So for the second integral we just got 3/4 minus root 3 over 2. If we distribute that, we'll get, let's see, an ln root 3 plus 1 minus 3/4 plus root 3 over 2. Okay, so that's the first part. That's where we have the sort of nonlinear function on the top and then the linear function below. Then we still have another integral. We have to find the integral from root 3 up to 4, and then the roles reverse. So this one first, then this one. So we're going to have to use another whiteboard for that. Let me go ahead and just approximate this one, so we'll have it. It's approximately 1.2 or 121. 1.121. Alright, so let's do that second half. We'll remember that what we got here, and we'll add them together for our total area bounded by those curves. So remember, now we're looking at this part from root 3, that intersection is root 3 up to 4. So right there, the area bounded between the red curve on top and the blue one on the bottom. Alright, so that's this area, and we can call that the second area, area 2. So from root 3 to 4, linear function is now the one on top. Remember that that function can be written as, if you split it up, as x over 2 minus 1 over 2. X over 2 can be written as 1/2 x, so that's this part, 1/2 x minus 1/2. Linear function first, minus other function. Okay, that's the integral we're finding. This integral is going to be extremely similar to the one we just did, so I'm going to go through it a little faster here. After you do the antiderivative and the fundamental theorem stuff, you get something that looks like this. Like I said, very similar to the last time. We're doing it faster. This one we made a substitution, u is equal to x plus 1, so that changed the bounds for the second part to root 3 plus 1, and then the top one should be 5, not 4. My mistake. Let me fix that. Should be 5 there. So I'll change that to 5. Okay, so now if we plug all that stuff in, we get all of this. So this is the plugging in 4 minus plugging in 3 minus this one ln 5 minus ln root 3 plus 1. So putting all that together, you get, according to the calculator, you get ln root 3 plus 1. minus ln 5 plus root 3 over 2 plus 5/4. And if you put all that together as an approximation, you get about 1.512. So if we take that and we put it together with what we got on the last one, you get this. So up to here, up to the 5/4 is what we just got. That's what we got the last time. There's some like terms here that we can combine, and if we do, we get this, and if you add all that up and approximate it, it is about 2.633. 2.633. If it asks you to round to the nearest thousandth or something like that. Alright, so pretty complicated problem here. Two different integrals that were not too much fun, but at the end, that's what we got, 2.633.